Hello and welcome to today's webcast, Self-Service Taken to the Next Level. My name is Raghav Pandey and I'm a Business Intelligence Analytics Consultant at Thorogood Associates and I'm based in our Singapore office. I'll start with a brief introduction to Thorogood and then move on to discuss my definition of self-service and responsiveness in the realm of modern data architectures and see why they're important. I'll highlight some of the foundational aspects of any self-service strategy, that is, where is your data and where it should exist, and then discuss how you take common approaches to self-service to the next level by identifying ways in which you can ease the process of analysis for your data consumers. We will finally wrap up today's webcast by looking at what the industry is doing and why our topic for today is most relevant in the background of these industry trends. For those of you who don't know us, Thorogood is an independent global professional services firm specializing in business intelligence, analytics, strategies, solutions, and services with a focus on our customers. We're a global company with offices in New York, Philadelphia, Boston, London, Bangalore, Singapore, as well as Sao Paulo in Brazil. All our consultants are recruited and trained in the same way to develop a unique mix of skills, blending business understanding in the form of industry and functional experience with strong technical aptitude and a deep understanding of analytical tools and techniques. We offer a full range of BI and analytics services, including strategy and roadmaps, requirements design, implementation, and training and support. In terms of the technologies we work with, we are an independent consulting firm, meaning we don't partner or work with one specific technology. We do, however, work with many of the key players in the market in order to provide our clients with a solution that best suits their needs. When thinking about self-service strategies, they're often made up of several different technologies which cover the platform. Reporting, analytics, DevOps, governance tools, and other components should principally be tool agnostic to be able to service future needs and requirements as well. Working with many technologies in the industry allows us to use the appropriate tools depending upon the situation. We also serve some of the biggest companies in the world and are in recent times helping them to define their strategy around digital transformation, especially around their move and expansion in the cloud and data science strategies using technology best practices and methodologies like DevOps, along with, of course, self-service to help them derive better business value from their technical solutions. So let's move on to talk a bit about the theory behind building a self-service and responsive platform. So why are we using the term self-service and responsiveness in conjunction? Well, I think they're pretty key topics to be thinking about together because we want our data platforms to enable users and let them satisfy their data and analytics needs. So for self-service, you'd often hear the term when discussing visualization, modeling, and data analysis tools. It's also a relevant topic for data platforms. To give it a definition, self-service is using strategy, technologies, and implementation patterns to put users in a position where they can readily access data and work with it how they want to. And we can think why that matters and what that does for us. Well, we remove the dependence on the IT organization within, each firm to produce all the data and solutions and applications, and instead give all individuals across the organization the opportunity to work with data. Instead of a small group being responsible for data solutions, we enable many people to do it to varying degrees. Likewise, we know user communities are starving to get access to data, whether it's new sources, log data, or maybe the ability to combine sources using tools they're familiar with. You want to enable key functionalities and capabilities. And then for responsiveness, and this is probably one that's a bit more foreign to individuals, but we're thinking about the ability to respond to change quickly and effectively, to build a platform that is very easily able to meet the data requirements or asks. We desperately want flexibility in our data solutions, so we're able to support user demands and provide data and analytics capabilities in a way that provides value now and into the future. Why do we care if the platform can respond? Well, we know data and analytics needs are going to constantly change, evolve, and become more sophisticated and frequent. A data platform should be able to shift with those needs. If it can't, it's not going to be effective and it's not going to provide any value. We know that things change rapidly and sometimes severely, whether it's a new data source or a new privacy legislation. The platform in general should keep up. So let's see how we can extract information from users to figure out how to make the platform responsiveness and to provide the self-service capabilities that is appropriate to your user group. This concept of personas actually has its roots in agile methodology. Some of you may be familiar with it or use it conceptually. The goal is really to think about who is using a product, and in this case, your self-service strategy. and what they want to get from it and how they want to use it as well. If we get a good view of users, we can build and then promote the platform to enable self-service ambitions and respond to new user needs. Here's a quick way to think about personas. Essentially, we're capturing key information from our users as to how they use their data, things they can't do now, their roles and ambitions, and the specific information which fuels the design and implementation of your self-service strategy. As with any product or service, it needs to be built with specific users in mind. And there's a quick exercise I like to use, and there are a number of adaptations like this, but it provides an avenue to think about personas and capture them. I think about who my user is and what their role is. I need to determine what is it that they want to do or functionality they want to have to help them do their job. And then I also want to understand why they want that feature or capability. If I develop a broad enough assessment of how my organization wants to use the data platform and what's driving those needs, I can then feed that into my design of my self-service strategy. And an interesting line I like to think about is understanding what's your self-service strategy and what it needs to do is as important as understanding how to technically build it. We constantly want to think about what's driving our design, our structures, and what's driving value in turn, and then figuring out how to technically deliver it. Building on from that, anytime you're thinking about a self-service strategy, you're often thinking about user personas. And there are many different personas in an organizations that will take advantage of the integration of data visualization, analytical models, and other data in different ways, each trying to get value in a different way. First, we have data scientists, and these are individuals who usually have the technical skills and do most of the data modeling and the creation of reports and analysis. Next, we have the consumers, who usually are the largest group within an organization, and they're just looking to get access to the information in order to get answers and insights for their specific use cases. Correspondingly, you have managers who probably look at things at a higher level and are not bothered about the lowest level of granularity when it comes to data. And they're supplemented by business sponsors who are more interested in seeing key trends and gaining insights that answer the broader business questions. Finally, you of course have executives who are probably your smallest group and are interested in only the key KPIs which dictate the health of the business. Creating reports for a broad audience like this with the different strategies that a company might have might become cumbersome. A data scientist, for example, might develop reports for the consumer group and correspondingly different reports for the managers, business sponsors, and executives as well. The problem occurs when each of these different groups starts demanding for more and more analysis, and what you end up with is multiple different reports and common pitfalls with most self-service strategies, which is there being different views and versions of the truth. So by giving access to data and reports to these different user groups, you're creating different versions of the business or the business performance, which makes it difficult to track and understand where things are going wrong. Further, there is duplication of effort. So with the same information being represented in different groups, in different reports for those different user groups, you end up with duplicating the effort of building those reports and doing some of the ETL transformation, other aspects, which goes into the building of the report as well. However, the idea now is to introduce just enough control to make it mitigate some of the concerns we saw in the previous slide, while still providing data consumers with the transparency and flexibility that they would appreciate. A robust security structure is often required, which allows for quick addition of individuals to appropriate roles, which in turn provides them the required access. A data catalog must also be available to users for them to just understand what exists and choose what is most relevant to them. In case data sets are being transformed considerably from their raw state, information needs to be provided about the changes made from the raw state to the finished product that users are essentially using for their analysis so that they can kind of appreciate what they're seeing. Security and control, of course, relates to my first point around governance, where appropriate checks and balances have to be put in place for providing access to individuals. Again, this should not actually be cumbersome for individuals who have legitimate needs. This should be a process which is seamless. Common design patterns also need to be exposed to individuals, and the options of analysis needs to be communicated to them. Your data stores need to be organized in an accessible way, where business relevant names have been used and data is available in a format that is also easy to consume. Additionally, when exposing this data, providing information about the true source and the modifications in between proves to be very useful for users as well. Finally, in what are key aspects, a future roadmap of the platform and corresponding empowerment needs to be provided for strategies to actually yield the results that you're looking for. So having mentioned data stores a couple of times, where should organizations be hosting their data for self-service? Well, the two most often used storage mechanisms for enabling self-service are data lakes and relational databases. Which one makes more sense for your organization or your team? Well, that is the question which relates to user personas and their different ambitions while using the self-service strategies. Each of these data storage mechanisms are widely used and more recently in conjunction with one another. And there are distinct advantages to each as well. For example, data lakes provide you the unlimited scale and flexibility in ingesting whatever kind of data you may need. For ad hoc analysis, when you're trying to get something in quickly and analyze alongside some standard data lakes give you the flexibility to do so. Additionally, the provision of access could be less complicated as well. Correspondingly, databases provide you with data integrity and data models which are ready to ingest and leverage for analysis. This becomes extremely attractive for those individuals who know the data they require periodically and aren't really looking to build things from scratch and analyze it. More specific security can also be applied, as well as allowing individuals to access only what might be relevant to their job roles. Further, the heavy processing of, say, appending or merging data, which is very common when actually trying to derive insights from data, can also be pushed down to the relational layer. So as a common approach to leveraging data from a data lake, you would usually pull through data from your local files or systems through your defined cloud architecture into folders which serve a specific purpose for a team having a particular need. This data, alongside common master data or hierarchical data, which is centrally maintained, can then easily be connected to using a reporting tool like Power BI. Furthermore, quick exploration would be available for those who need that scale that something like a data lake can provide. And the usage of automated machine learning or drag and drop machine learning tools can be brought into use. The data available in the data lake can be used in conjunction with these tools to perform a first pass to understand whether there are insights worth chasing in your data. Correspondingly, if you want to bring in further data integrity into the process and provide individuals with a layer that handles the modeling for them and additionally contains the outputs of ML models, an in-between database or a relational layer will do that for you. This brings an element of control to the entire process and possibly increases the lead time of having something available for analysis. But for those of you who are okay to wait and would rather prioritize integrity over speed, this poses as an attractive option. But do note, the two types of data stores which I've just talked about best work in tandem. A strategy which leverages the best of both gives individuals in your organization the flexibility to choose what they want. But what if amongst your user personas, there are individuals who want to access the data but not necessarily want to prepare and model it for reporting? Or alternatively, they just want an intuitive interface to pick the data sets that they would like to report on and have all of the data preparation and modeling needs already handled. And also, what if your individuals want to consume data science and have access to advanced insights on their particular data sets? Let's actually see some examples of the customization you can bring into your self-service strategies to enable those kinds of asks and take your self-service strategy to the next level. So moving from the common design pattern of a data lake supporting your self-service, which I just showed you in a previous slide, we can take it to the next level where we automate more aspects of the chain and in turn provide ease of use. What we actually have here is the actual architecture of the prototype Thorogood has built surrounding a self-service data lake ingestion tool. This self-service tool automates the ingestion of data by a business user into a data lake and dynamically generates a Power BI data model for reporting and analysis. During the self-service process of data ingestion, this tool enables a user to analyze the newly uploaded file along with existing data assets in the lake. Before I begin to explain this in a little bit more detail, these were just the tools we chose in our particular scenario with the access we had available to build this particular data lake ingestion tool. But obviously, the tools could depend upon your particular situation and can be changed or reevaluated depending upon the use case. So to begin, users actually interact with Power Apps to upload a file into the data lake. Power Apps can read and write back to a data catalog that is being stored in a SQL database, for example. Power Apps then pushes the file into the raw layer of the data lake, which Databricks reads, transforms, and pushes to other layers. Finally, Databricks is triggered again to run a code that automatically creates a Power BI model. Upon creation of the model, something like Power Automate can also be utilized to send an email notification to the user, which indicates the creation of the Power BI model, as well as connecting back to the dataset which they originally loaded. This cycle allows users to kind of control what they see and need and provide intuitive ways to align to schemas and structures defined. No real code or no knowledge of modeling techniques is actually required from the users, and they can leverage the analysis which something like this provides on top of their data sets in conjunction with other data sets that they might have available as well. Similarly, with the relational layer in the mix, we can take this to the next level as well. A custom interface could be provided for individuals to make the data set and other parameter selections they require, and then have Power BI models ready for consumption. This is actually what we did for one of the leading mining companies in the world, where easy on-demand access to third-party data was of paramount importance to help inform their strategy around commodity prices. The challenge that the client faced was a common one. Firms in the mining sector rely upon a wide array of external and internal data sources to inform their analysis of market factors. The greater the supply of data, the greater the challenge in gleaning the signal from the noise in order to accurately project commodity prices. It needed to identify the most relevant performance indicators within its trove of market, commodity, and macroeconomic data sources, and needed to give its analysts access to this data in a targeted, comprehensive, and easily digestible format as well. So, built using the Python-based Django Web Framework, the Django REST API, and React, this Thorogood developed app allowed users to select their desired configurations of prices, geographic locations, time intervals, and currencies, among others. And by connecting all of this together, you were able to leverage that single data layer which was available within the company, and also look at it specifically for exactly what you wanted to look at. Thorogood could also then use this model to serve the needs of Power BI, Excel, and browser users for quick access to the key performance indicators they relied upon most. You can read more about this engagement of ours on our website, where we have a detailed use case and a case study as well, talking about the business situation and the solution we were able to create to address the company's need. And as stated earlier, to address the ask of consuming data science on top of your data, the cloud provides you with several different options to do so, each fit to purpose. If you're in the Microsoft Azure cloud, for example, you have a few options. For large-scale, complex models requiring customization of standard ML algorithms, you could utilize something like Databricks to develop a model whose output a self-service user could connect to, and I will detail how in a quick minute. Along with this, if you're looking to utilize a standard machine learning model which doesn't really require customization, self-service users could actually directly leverage models that they or others might have built in Azure ML in something like Power BI. And finally, pre-built cognitive services APIs in Microsoft Azure would help with text or sentiment analysis, and these are easy to consume within something like Power BI as well. So no one tool can do it all. There are a variety of things that modeling tools and data visualization tools are very good at, and a variety of shortfalls for each as well. So most visualization tools are great at displaying data and creating beautiful dashboards. Their main purpose is to visualize data and make it easily accessible and understandable to many people. And they're excellent in that area. Each has its own modeling capabilities, but these capabilities are sparse compared to proper modeling tools. Tools like Tableau and Power BI have limited compute, not many features like in modeling tools. And that can decrease performance if there are too many calcs or calculations, or you cannot perform more elaborate analytics as well. In a similar way, analytical modeling tools can easily do all the things that the visualization tools mentioned before cannot. But their downfalls are in creating interactive and shareable reports. Many have some basic visualization capabilities, however, they lack the myriad of options that tools like Power BI and Tableau bring. The reports are most often static and limited, and there are only limited customization options, and it's often tricky to share them across an organization. What we need is a powerful, reliable compute that offers machine learning and programming functionality, And we need a way to simply and clearly visualize insights from data science investments as well. And luckily, you can use both of these together to solve many of the gaps that each of these types of tools has. Pairing analytical modeling and visualization tools together will allow you to leverage the best qualities from each and provide you with an opportunity to productionize analytics and share insights, make data science understandable for the whole organization, and make insights actionable as well. And with that in mind, using something like Databricks, which essentially is a data engineering and a data science platform built on Spark and would allow you to do complex analysis and detailed analysis on large data sets, essentially it's very easy for you to connect something like Power BI to Databricks. Access to the Databricks cluster, which is the compute, is all you require, as any tables having the outputs of analysis stored on it will be accessible to Power BI, just like if they were from a relational layer like a database. Similarly, with models built using Azure ML, you can directly consume them in Power BI if you have something like read access to your organization's Azure subscription. So something like that might be rare to get, however. So a quick Python script, which you could then provide as a template to users, will allow them to consume the model within Power BI and also allows users to upload whatever data they would want to obtain insights on using the Azure ML model. And finally, with cognitive services, the approach is very similar. In general, to enable the connection between user needs and machine learning models, there are multiple methods in place. And template reporting applications can be built and distributed to consumers who need those advanced insights. As I wrap up today's session, I thought it would be useful to touch upon what the industry is doing in terms of making it easier to access data available within an organization. Among the major players in the technology space, there's a clear effort to bridge the gap between consumption of data and advanced insights and the visualization of the same. Microsoft's new offering of Synapse Analytics, which is a new and improved version of their SQL data warehouse, looks to combine all elements of data management into one location, providing a seamless experience between loading and consuming insights from data. Power BI, on the other hand, continues to expand its functionality and connectors by giving you direct access to the Azure cloud offerings like AutoML, which will help consume machine learning models on top of your data on the click of a button. While Databricks has recently bought Redash, and with that within its fold, it's able to provide additional visualization capabilities on top of large-scale ETL and data science. So the industry is moving to bridge the gap between these different aspects of the data lifecycle and removing the silos in which people had operated so far. This presents a wonderful opportunity for most organizations to take the efforts to truly democratize the use of data and invest in their self-service strategy right now. My contact details can be found on the slide. And thank you very much for joining us. Have a great rest of your day.